our study shows the location and shape of seafloor pathways, and what we've done in the paper, what we presented is that the nearest oceanographic observations near Totten Glacier show this very warm modified circumpolar deep water beneath 400 to 500 meters below the surface of the ocean.
But a dangerous process is now going on beneath the ice shelf, bringing dramatic changes. They're being driven by what's called Circumpolar Deep Water, or CDW. For some time now in western Antarctica, it's been flowing from the depths up towards the surface. Because it's comparatively warm, CDW melts the shelf from below. Satellite measurements have now revealed that for years, the line where the ice is solid all the way to the seabed has been retreating. This is a critical development because the ground beneath the ice shelf is tilted towards land. So the water is growing deeper beneath the pack. That causes migrating ice to speed up on its trip to the sea.
The reason why you can get warm water beneath cold water is this particular water mass is saltier than the fresher water that we find near Totten Glacier, and also this is occurring in West Antarctica. So it's not intuitive that warm water can be below cold water. You know, we learned in 8th grade physics class that that warm air or warm water rises above cold water because it's normally more buoyant. But the salt content of this water forces it down. And so this really warm water can flow along these seafloor gateways into the cavity of water beneath the floating Totten Glacier. So there's been observations close to Totten Glacier dating back to 1996 on at least 4 different expeditions that found this warm water to the east of the glacier on the continental shelf. And because the predominant current in Antarctica near the coast is east to west, our physical models show that this water will flow along bottom topography into the Totten Glacier. There was actually a press release that I noticed recently put out by the Australian Antarctic Division that claims to have observed this really warm water very, very close to the glacier. So although we've identified these deep pathways that connects the continental shelf where these observations have been made to the interior of the glacier, what this suggests is that now might be the time to consider sending robotic assets beneath the ice shelf to see what happens to that warm water when it goes into this ocean cavity. The only other place that's been done was beneath the floating section of Pine Island Glacier in West Antarctica, which is the most rapidly thinning glacier in West Antarctica. So I think, among other things, one thing our study should encourage is considering deploying assets like that to this glacier in East Antarctica to see what happens to that water once it goes beneath the floating ice shelf.